Hey everyone, it's Matt here. Welcome back to another episode of Savant's Tech Talk. Like how the idea of classical computers seemed revolutionary in the 1950s, quantum computers have established themselves as the next step in computing. They could be the breakthrough that we're desperately in need of, especially in regards to climate change. From the formation of new materials to the discovery of new pharmaceutical treatments, quantum computers can have a major influence on everything. Quantum computing comes with the potential to leverage the forces of nature in our effort to prevent and eventually even possibly reverse climate change. This could include carbon sequestration, water electrolysis, and the development of new batteries, for example. Things have a tendency to work differently when the atomic level is concerned. Physics at the quantum level, for example, has different rules from those that we can normally observe. Such rules are responsible for governing how atoms engage with one another. And this new knowledge will allow us to apply quantum rules for extremely complex and fast computations that are much better than the capabilities of the conventional computers that we use today. A quantum computer, unlike classical computers, possesses the ability to evaluate all the possible ways to solve a problem simultaneously rather than sequentially. As a result, you end up with a computer that can theoretically execute these quantum level computations at rates significantly faster than even the best computers now in use. In today's video, we'll look at quantum computing and what it means for the environment. As always, if you find this topic interesting, then you can let us know by hitting that like button and subscribing to this channel for more videos. You can also let us know if you find it interesting by saying so in the comments section down below. Now let's jump into it. The environmental impact. According to one of the originators of the quantum computing movement, physicist Richard Feynman, said that nature isn't classical, damn it, and if you want to make a simulation of nature, you'd better make it quantum mechanical. And this implies that when it comes to climate change, carbon dioxide emissions in the atmosphere and their reversal via clean novel fuels and power storage are processes that must be observed at the quantum level. Our research into climate change management aims to fully comprehend the atomic level forces at work when molecules bond with one another or split. This information might allow us to develop new methods and equipment that will be extremely valuable. Even the fastest and most powerful computers available today don't even come close to the level of performance required to simulate quantum level interaction. Even by bringing Moore's law into the mix, they wouldn't be able to achieve this level of power in 1,000 years. On the other hand, quantum computing could achieve the performance required in the next decade or two. This is because it can simulate quantum forces of nature by utilizing quantum states of atoms. Quantum sensors. According to experts in the field, quantum computing can also monitor the environment in ways that traditional sensors and detectors aren't able to. Quantum sensors will become a valuable tool in the attempts to collect data that will help scientists clearly understand climate change and devise plans and policies accordingly. Quantum sensors are a representative of an entirely new method of monitoring our surroundings, allowing optimizations and correlations that were previously unthinkable. When climate change comes into question, these sensors are expected to have a revolutionary effect on a wide range of domains, from providing power to environmental monitoring. Better batteries. Batteries are expected to play a significant role in our transition to renewable energy sources. These batteries would not only power our automobiles, but they would also serve as an important energy storage technology in terms of renewable energy. Today's modern batteries, on the other hand, don't have the energy density required for lengthy travel and are too costly for energy storage in the long term. More recent battery research and development has been based on extended cycles of testing and computing simulations. Quantum computing allows for the simulations of every component of battery chemistry in a virtualized experiment at the quantum level. In virtual experiments, certain factors like electrode materials, electrolyte formulae, binders, and separators may be adjusted and analyzed to determine the combination that would permit a breakthrough in energy density. Energy efficient. According to some of the experts in the field, due to quantum computing's computational effectiveness, it has a more direct impact on climate change. So to put it another way, once these computers have reached a certain point, they could be exponentially greater at solving problems in comparison to conventional computers. In fact, in the instance of computation that Google did on their quantum computer to accomplish quantum supremacy, the quantum computer utilized around 557,000 times less power than a modern supercomputer would have. So to sum it up, quantum computers will be much more efficient in terms of the actual resources needed, like the overall energy required to accomplish a specific calculation. So there we have it, a look at quantum computing and what it could mean for the environment. Once again, if you found this video interesting, don't forget to let us know by hitting that like button and subscribing to this channel for more videos. Thank you for watching.